Hello friends, in today's video I'm going to show you the functionality of a proof of concept of an AC phase controller being controlled through Modbus TCP Industrial Communication Protocol. I'm going to explain first of all a high overview of the theory of AC phase control. In the second place, I'll explain the main Modbus protocol parameters being used inside a PLC S71200 to communicate with the AC phase controller device. And in the third place, I'll show a demonstration of 3 applications this controller can be applied to. In this case, we're going to talk about the single AC phase controller. This technique is very used to connect and disconnect a given load from the power line based on a computed triggered angle alpha that we'll talk about later. So here in my country we have the following AC signal in the main power line, 127 VRMS at a frequency of 60 Hz approx. If we plugged an oscilloscope, we'd see something pretty similar to this. So let's define our function as A times sine function of omega t. So let me highlight some important features of this signal. We can see that it has a positive cycle and a negative cycle, and it is also a periodic function, so the absolute value of the integral of the second part of the cycle will be the same as the first half. That fact actually allows us to compute only one part of the signal, as the result will be the same for the second part. Here we have how the integral of our function looks like for the first half of the cycle. Now let's put it in a percentage expression. Here it is. This curve / expression shows how many on time we should have for a given desired percentage of the half cycle. This expression would be ideally inside the microcontroller if the application requires so. You'll probably find some papers where they consider the angle as the off time instead of the on time, as we did. Let's get the complement of our response and compare these graphs. As you can see, the equation is not linear and should be taken into consideration for certain applications. I have created a Python script to simulate how the AC waveform would look like for a given desired percentage value. And here we can see the computation at 20%, here at 50%, and here at 70%. Now, regarding Modbus Industrial Communication Protocol, we need to take into account that the final intention is to inject a value from the PLC to the developed device. So we'll need to use Modbus mode 1 in our configuration block, which will allow us to write analog output holding registers from 40,001 to 49,999. In this way, we'll be able to send a word data length to the microcontroller for the desired final signal percentage. As we've seen in the last video, we can use a wired Ethernet interface, or we can also use a Wi-Fi remote connection to control this kind of devices. In this case, I'll show a demonstration of a wired connection. I'll show a quick mock-up box to test the previous concept I've explained. This device has available an Ethernet port, an LED bar light, an AC power output, a reset button, a knob to change the amount of desired power manually, and a selector switch. On the back, we can find PCB holders and DIN rail holders. I've implemented the same Modbus reading as in the previous video, but now to see in the HMI what the current AC trigger angle is active. I have coded some conditions inside the PLC for a low and a high operation threshold, which can be both modified in runtime. So having the selector in manual mode, I can turn the knob to modify the trigger angle, and this value will be reflected in the HMI. Now if I enable the remote mode by changing the selector switch, I can send the desired trigger angle from the HMI through Modbus communication protocol, and the same operation thresholds will apply. We can also connect different kind of loads. Here is an example using a motor tool that is going to be driven by this device too. And last but not least, it can be used to control bigger loads as a drill, for example. It will all depend on the power ICs you choose. Great, so thanks for watching.